Assalamualaikum dan salam sejahtera. So today's lecture is on the topic of gravitation. We are going to see, ini adalah topik baru bagi anda sebab you have not covered this topic in your form 4 or form 5. So we are going to see the gravitational force yang selama ni awak kira yang G sama dengan 9.81 tu datang daripada mana. We are going to see potential energy. We are going to see how work is done in bringing a satellite from outer space back to the Earth. Okay, kita akan tengok banyak lagi subtopik dalam topik gravitation. Okay, the first, ini adalah introduction to what is gravitation. Okay, gravitational force is one of the natural fundamental forces in the universe. Okay, it is one of the natural forces, maknanya dia tidak dibuat, dia memang ada secara tabi'i. Okay, there are only 4 fundamental forces from which everything else is derived from. That is the strong nuclear force, the force that holds subatomic particles together in the nuclei of atoms. Okay, ini adalah daya yang ada antara dalam atom tu. Kita ada banyak, kita ada elektron, kita ada proton, kita ada neutron, and what holds them together as an atom is called the strong nuclear force. Okay, it is held dia sangat kuat, dia boleh pegang benda tu supaya dia tak bersepai lah. Atom tu dia satu atom yang secara natural dia memang held together. Okay, so the weak nuclear force. Okay, weak nuclear force yang salah satu daripada fundamental forces. Ia didapati daripada radioaktif atau beta decay. Okay, when you have radiation emitted, you have all these sinaran, alpha, beta dan gamma. Okay, one of the beta decay itu bila dia decay, dia akan mengeluarkan weak nuclear force. And the third natural fundamental force is the electromagnetic force. Okay, this electromagnetic force is what holds the atom atau molecule together. Okay, when you have macam garam and ACl dan lain-lain lah yang ada molecule. Okay, electromagnetic force ni adalah apa yang memegang atom-atom menjadi satu molecule. Okay, dan the last but not least is the gravitational force. Gravitational force is the force that governs any two objects. Okay, dia adalah satu daya tarikan yang wujud secara natural di antara mana-mana dua objek. Okay, so the last statement says that the entire universe is held together by the gravitational force. It is therefore the most important force in nature. However, when kita akan tengok lepas ni, of all the fundamental forces, it is one of the weakest. Dia mempunyai, jika anda melibatkan masses yang sangat kecil, nilai dia adalah sangat-sangat kecil. Okay, we are going to look at Newton's law of gravitation. Ini daripada Isaac Newton. Everybody knows who's Isaac Newton. Ini kalau baca atau buka internet atau tengok cerita dia macam mana dia dapatkan law of gravitation ni, dia duduk bawah pokok apple. Di mana apple tu jatuh atas kepala dia. Lepas tu dia question why the apple drops daripada atas ke bawah on his head, not the opposite way. So there must be some forces yang menarik apple tu dari atas pokok ke muka bumi. Okay, so he thought about it a lot. So he published the law of gravitation in 1687. And it states that, by definition, every particle of matter in the universe attracts with every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. So this is in statement form, the brown, yang kita highlight brown tu. So the magnitude of the gravitational force can be written in the equation. F subscript G sama dengan G M1 M2 over R squared. Where M1 M2 ni adalah the particles masses. As I said before, this law of gravitation ni melibatkan dua masses. Okay, so M1 is one particle's mass, M2 is another. So R is the distance between these masses. And G, yang big G tu, capital G is the gravitational constant. It holds the value of 6.67 times 10 to the power of -11 Newton meter squared per kilogram squared. Okay, kalau tengok dalam practical 4 awak, amali anda, on the topic of gravitation. Nilai G ni adalah apa nilai yang awak cari. Okay, so 6.67 times 10 to the power negative 11. It is called the gravitational constant. Right? So, kita tengok juga, the statement can be shown by using the figure below. Okay, when you look at the figure, dia ada M1 yang di bola kuning tu, M2. Okay, when you look at the force, force adalah suatu quantity vector, dia ada magnitude dan juga ada arah. So, when you look at Fg sama dengan G M1 M2 over R squared tu, okay, so the forces ni, dia bertindak antara dua masses ni. So, you have one force that is F21, that is the gravitational force exerted by particle 2 on particle 1. 1, 2 tu Okay, and F12 is the gravitational force by particle 1 on particle 2. Okay, the direction is usually opposite. It is always attractive to one another. Okay, and R is the distance between the two masses. Okay, a few statements tentang the Newton's law of gravitation. Okay, gravitational force ni, Fg sama dengan G M1 M2 over R squared ni, it always act, daya ni selalu bertindak along the line joining the two particles, where they form action-reaction pair. Okay, when you look at the diagram just now, kita tahu force ni ada arah, dan arahnya selalu pada line, line joining the two particles. Okay, dan dia selalu opposite direction of one another. So that's why you call an action-reaction pair. Okay, even when the masses of the particles are different, contoh M1 ada mass lain, M2 ada mass lain, the interaction forces atau forces yang bertindak antara kedua ni ada magnitude yang sama. Magnitude yang sama, nilai yang sama. Sebabnya kita pakai formula Fg sama dengan Gm1 M2 over R squared. Whenever you insert M1, M2 berbeza pun, dia punya magnitude masih sama. F12 dengan F21 sama, tetapi dia mempunyai direction yang berlawanan. Okay, then the third statement says that exactly at the center of the earth gravitational force on a body is 0. Okay, it's saying that pada pusat bumi, pada pusat bumi yang tertengah tu, earth dengan dalam bumi, gravitational force adalah bernilai sifar. Okay, jadi jangan percayalah kalau cerita apa to the center of the earth tu kan. Dan kalau tengok movie tu, dia ada gambar dinosaur lah, apa dalam tu ada laut-lautan. Okay, itu hayalan sahaja. Okay, dalam tengah-tengah perut bumi tu, earth gravitational force is 0. So, the gravitational force is always attractive, never repulsive. Okay, dia selalu dalam keadaan tertarik dengan satu sama lain. Dia tidak pernah menolak. Okay, you're going to see another electromagnetic force. Nanti dalam topik states of matter, perangai dia lain. Perangai dalam electromagnetic force tu, dia ada attractive dan ada repulsive. Tetapi dalam Newton's law of gravitation, the gravitational force is always attractive. Okay, and the Newton's law of gravitation defines the strength of this attractive force between the particles. Okay, so when you use this equation, Fg sama dengan Gm1 M2 over R squared, okay, when you get the value, if the magnitude is high, maknanya tarikan di antara kedua-dua mass itu adalah kuat. Okay, dan bila dia mempunyai nilai magnitude yang rendah, maknanya ada force antaranya, tetapi dia nilai dia sangat sikit, jadi kita tak boleh rasa. That's why when the apple and the earth tu, okay, for apple and earth is around 0.8 Newton. That's why it falls down. Dia tertarik pada the center of earth. It goes down. The apple drops from the tree. It doesn't go back upward kepada langit. Okay, so the magnitude for two people, the gravitational force is kurang daripada 1 micronewton. So you walk around between your friends, awak ada daya tarikan di antara awak dengan kawan awak. Okay, daya tarikan secara fizikal. Okay, tetapi sebab nilai dia sangat-sangat kecil, awak tak tertarik dengan dia, bukan melekat macam kembar siam tu. Okay, because the value of the force of gravitation is very, very small. Right? Okay, when you look at the equation just now, Fg sama dengan Gm1 M2 over R squared, okay, tengok ada satu constant wujud. Kerana by definition, F is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Alright, so in order for you to have the equal sign, you must introduce a constant. So G yang besar, capital G tu, is called the gravitational constant. So the gravitational constant G ni is a universal constant because the gravitational force between two bodies placed at a certain distance remains the same wherever the body may be placed in the universe. So gravitational constant ni mengatakan bahawa kalau masses tu massnya tak atas bumi ke, dekat outer space ke, nilai dia masih sama menggunakan constant ini. Okay, so the value of G ni dalam SI unit adalah 6.67 times 10 kuasa negatif 11 Newton meter squared per kilogram squared. Okay, very small, times 10 to the power of negative 11 indicates that the gravitational force is an extremely weak force and becomes important only when the masses of the yang dalam equation tu are very large. Okay, contohnya the small g memang mengatakan bahawa force gravitational force ni sangat-sangat kecil value dia. Dia tak boleh dirasai. Dia satu daya tarikan tapi dia tidak boleh dirasai between masses yang kecil. Tetapi when it involves masses yang besar seperti bulan, matahari, planet-planet, okay, then the value of the gravitational force becomes very large. So that's why bila awak send a satellite above the earth, okay, it has dia buat dia punya orbit, orbit dia membulat, it is always pulled by the gravitational force. Sama juga kita bumi mengelilingi matahari, okay, dia ada dia punya laluan sendiri, and it is governed by the gravitational force, right? Okay, then there is another. This is dalam gambar slide ni menunjukkan satu experimental procedure macam mana nak mencari nilai G secara dalam makmal. Okay, when you look at this experimental apparatus ni, kalau awak Google dia, this called the torsion balance. Okay, when you Google it atau cari di internet, dia ada cerita macam mana nak cari. So I won't elaborate in my lecture. You just have to know the G can be experimentally extracted and dinilai daripada experimental procedure ni. Okay, it is called the torsion balance. Right? So we look at an example. Okay, a 50 kilogram person and a 75 kilogram person are sitting on a bench so that their centers are about 50 cm apart. Okay, bila anda melibatkan macam orang ni dia ada center mass. Kalau yang tinggi, center of mass dia tinggi lah. Kalau yang rendah, ada center mass yang rendah. Kita pula ada unjuran-unjuran tangan dan kaki. So, you have studied center of mass dengan Dr. Zainal. Bila ada manusia ni, kita tak tahu center dekat mana, kita kena carilah. Okay, so you have these two person, 50 kg and 75 kg. You don't know whether they are short or tall. They are sitting on a bench. Okay, dan dia kata center dua mass ni, orang dua ni, dia berada 50 cm apart. Maknanya sekarang ni center dia berada pada satu line of action yang samalah. Okay, so estimate the magnitude of the gravitational force each exerts on one another. Right? So, from the equation for the magnitude of the gravitational force, Fg sama dengan G m1 m2 over r squared. So, taken as m1 ni adalah person yang pertama tu 50 kg dan m2 adalah person yang kedua tu 75 kg, and the distance between the two objects is 50 cm. Okay, dan kita convert when you want to insert data into an equation, you must convert all the data into SI unit. Jadi diberi dalam soalan tadi 50 cm ya. Kemudian you have to change it to meter because that is the SI unit for length. Okay, so you have the gravitational constant at 6.67 times 10 to the power of negative 11, and you have the person, dua-dua orang tu punya mass dalam kilogram, betul, SI unit dia. Dan you have to convert 50 cm tu kepada meter, that is 0.5. when you insert all the data from the question into the equation, you have the answer, the force between them, the magnitude between them as 1.0 times 10 to the power of negative 6. Okey, dua-dua force ni yang 75 kg kenakan kepada 50 kg person tu, magnitude dia 1 darab 10 kuasa negatif 6, dan yang 50 kg ni kenakan kepada 75 kg ni pun sama magnitude dia, 1.0 darab 10 kuasa negatif 6. The difference is that between these two forces adalah direction dia saja. Dia adalah opposite each other. Okay. Okay, when we look at another example, okay, the average distance separating the Earth and the Moon is 384,000 km. Okay, jarak purata antara bumi dengan bulan adalah 384,000 km. Find the net gravitational force exerted by the Earth and the Moon on a spaceship with mass of 3 times 10 to the power of 4 kg located halfway between them. Okay, now we have the Earth, katakan on the right hand, okay, and the Moon at the left hand. Okay, jarak antara dua ni 384,000. Then there is the satellite, berada di tengah-tengah di antara Earth dan Moon. Okay, maknanya tengah-tengah lah, located halfway between them with a mass of 3 times 10 to the power of 4. Okay, bawah ni diberi, bawah tu given G, the value of the constant G, mass of the Earth is given, and mass of the Moon is given. Now you're trying to find the net gravitational force. Okay, so now first of all there is the F Earth ni, yang Earth kenakan ke atas satellite, because the satellite is halfway between the Earth and the Moon. So now we calculate first the force yang Earth kenakan ke atas satellite. Okay, so between the Earth and the satellite, the two masses, you have to insert the data of the mass of the satellite and mass of the Earth into the equation, dan jarak di antara Earth dan satellite itu, bukan Earth dengan Moon, Earth dengan satellite, because the distance between the Earth and the Moon is given and the satellite is located halfway, so bagikan kepada dua jarak dia, so you get around 1.92 times 10 to the power of 8. Okay, when you insert all this data into the equation, you have the force yang Earth kenakan ke atas satellite sebagai 325 Newton. Okay, then that is the first force. Then the second force yang Moon kenakan ke atas satellite. Okay, so the object now is between the Moon and the satellite. Okay, sama juga dia punya jarak di antara Moon dengan satellite, because the satellite is halfway between the Earth and the Moon. So bagi dua, it has the same value as the jarak antara Earth dengan satellite as 1.92 times 10 to the power of 8. Okay, masukkan data semua ke dalam formula tu, you get the answer as 4 Newton. Okay, 4 Newton because saya tengok beza 325 dengan 4 Newton. Sebab apa? Perbezaan di antara mass of the Earth and mass of the Moon. So now they are trying to find the net force. Okay, dia bukan nak satu-satu, dia nak net force, combination of both on the satellite. So you have it as 1, if you take the Earth, okay, the direction of the Earth yang kena force the direction yang force Earth kenakan ke atas satellite, you take it as positive. Okay, 3 to 5. Then I told you the answer is an action-reaction pair, even though the magnitude is the same ke apa, the direction is always opposite. So the other one, the direction of the Moon, okay, force of the Moon yang kenakan kepada satellite is taken as negative. So that's why you have the F resultant, the net force, as 325 minus 4 Newton. You have 321 Newton towards the Earth. Okay. Okay. Now we go to another subtopic, that is gravitation near the Earth's surface. Okay. Before this, I've told you secara random yang gravitation ini adalah force di antara dua objek, dan selalunya gravitational force ini bukan selalunya, dia di center of the Earth, the gravitational force is 0. So now we are going to see a value yang awak pakai selalu tu, G sama dengan 9.81. Mana dia datang? Okay, so when you combine, you know that the gravitational force is Fg sama dengan G m1 m2 over r squared. Okay, then you have Newton's law juga. Isaac Newton's law ni datang F equals to ma. So now kita nak tahu acceleration, gravitational acceleration A to AG tu. Okay, so when you combine the Newton's second law, F equals to ma, with gravitational force, you have G m object m earth over r squared equals to m object AG. Okay, saya subscribekan semua supaya awak tahu apa yang kita nak cari sebenarnya. Okay, so katakan awak M object, awak tu, yourself is the mass of the object. Okay, so Gm object M earth over r squared is the gravitational force yang dikenakan ke atas awak bila awak berada di atas muka bumi. Okay, dan Ma is your daya yang dikenakan. Okay, daya yang membuat awak berdiri di atas muka bumi tu, dia M object, your mass, times the gravitational acceleration yang menarik awak ke muka bumi tu. So when you look at both sides of the equation, you have similarities dari segi parameter M object tu. So you can cancel it off. So kita nak tahu acceleration ni, gravitational acceleration AG ni is Gm earth over r squared. Okay, when you simplify the equation tu, awak nampak yang gravitational acceleration ni bergantung kepada mass of the earth and the distance between you and the earth. Itu sahaja. Okay, so the gravitational acceleration is due strictly to the gravitational force exerted on the object by the earth. Okay, so this gives the magnitude of the gravitational acceleration at a certain distance from the center of the earth. So R ini, R you know is the mass, is the distance between the two objects. Now if it is between you and the earth, okay, so the distance is between the center of the earth to your center of mass. Right, so kita tahu distance dia adalah selalu antara center of earth dengan mass object tersebut. Center of mass object. Okay, so sekarang ni kita tengok. Okay, now when you have that equation, bila awak gantikan R yang berbeza, nilai R, saya dah katakan tadi, nilai R selalunya daripada center of earth to where the object is. So katakan objek itu berada pada permukaan bumi. So when you calculate, you masukkan the distance between the center of earth to the earth surface, okay, dan n object, apa-apa objek, you akan dapat gravitational acceleration ni sebagai 9.83. Yang awak ambil selalu 9.81. Okay, sebabkan atas permukaan bumi ni dia ada banyak, dia ada berbeza-beza nilai dia. Bila awak dalam valley, atas permukaan tanah pamah, atas bukit, dia ada different height. So it changes slightly. Okay, so average dia ada 9.83. Okay, bila altitude dia naik, ketinggian, katakan awak pergi Mount Everest, duduk atas Mount Everest. So the altitude is around 8.8 kilometer. Okay, so you have the distance from the center of the earth to the permukaan. Lepas tu distance dia adalah center of earth kepada permukaan campur 8.8 km sebab awak berada di atas gunung. Bila awak masukkan into the equation, the value changes to 9.80. So you expect with 9.80, okay, awak punya weight pun akan berbeza. You become lighter. So siapa nak kurus ni naik atas Mount Everest. So because the acceleration, gravitational acceleration is affected, dia affected yang value dia. Okay, so bila awak naik balloon, high screw balloon yang gas panas tu, okay, you will go about 36.6 km dari atas permukaan bumi. So the gravitational acceleration pun berubah kerana the higher the altitude, the less the value of the gravitational acceleration. So you get around 9.71. So when you are in a space shuttle orbiting around the Earth, okay, at around 400 kilometers above the Earth's surface, your gravitational acceleration is 8.7. Okay, then when you go on a communication satellite is also called a geosynchronous satellite, di mana it orbits around the Earth, sekali dia pusing 24 jam. Okay, dia berada pada altitude 35,700 km above the Earth's surface. So, the gravitational acceleration yang dirasai oleh orang yang dalam communication satellite itu adalah 0.225. That's why sampai tahap you feel weightlessness. Okay, awak akan terapung-rapung. Then, because daya gravity itu tidak lagi dirasai. Okay, the further you are from the surface of the earth. Right? Okay, this table shows the variation. Okay, perubahan nilai gravitational acceleration dengan ketinggian. Okay, that is from the surface of the earth to ke atas, keluar. Okay. Okay, now we look at, okay, even though you're using the formula to calculate the acceleration, gravitational acceleration, bila kita boleh juga measure, okay. So the calculated AG when you use the formula will differ slightly from the measured AG at any location. Okay, ini secara realitinya pun ya. Katakan awak pergi ke Kutub Utara. Kutub Utara mempunyai gravitational acceleration yang paling tinggi. Kutub Utara dan Kutub Selatan mempunyai gravitational acceleration yang paling tinggi. Katakan awak pakai 9.81, dia mungkin 9.88. Okay, dia differ, dia berbeza dengan kita di khatulistiwa ni, because the earth ni it's not really round. Okay, dia bukan betul-betul bulat. Okay, dia bentuk lonjong, dia buncit dekat equator. Dekat khatulistiwa tu dia kembang sikit. Okay, so people living on the equator macam kita ni kat Malaysia, di atas garisan khatulistiwa, akan merasai G yang paling minima di atas bumi. Okay, kalau you ambil 9.81, we may experience 9.8. Okay, 9.79. Okay, that's why kalau nak cakap khatulistiwa ni orang paling di kategori orang gemuk. Sebab apa? The bigger the value of gravitational acceleration ni, your weight also akan naik. Okay, the calculated weight lah. So the calculated gravitational force ni dikatakan berbeza, okay, di antara measured G dengan calculated G disebabkan 3 sebab. Okay, Earth mass, first of all, Earth mass is not uniformly distributed. Okay, salah satu sebabnya adalah, you know, bumi dia bukan satu sfera yang keras. Dia on the outer surface saja, surface dia aja keras, tanah. Tapi dalamnya, dalam core-nya, okay, dalam core mantle dia adalah liquid. Okay, so the earth ni dia bukan rotate tegak pun, dia rotate slightly tilted 10 degrees ke tepi. Okay, bila dia rotate, this liquid inside the earth will berkocak lah orang cakap. Dan cakap blender, dia berkocak. Okay, then liquid ni yang dalam earth ni terdiri daripada macam-macam benda unsur. You have metal, you have copper, you have all those segala benda ada dalam. So ada certain time when the earth rotates, the things that has mass yang tinggi, katakan iron semua, dia berada pada satu tempat. Katakan bawah Sweden. Then the earth rotate again. Then dia berkocak pula dalam tu, dia pindah satu lagi tempat. Okay, even though secara purata you can take the earth mass as 5.98 times 10 to the power 24, it will differ slightly at different places. Because bila dia rotate, liquid dalam tu akan berubah tempat lah. Okay, so of course it affects everything, not just the gravitational force, it affects also the magnetic force yang keluar daripada kutub utara, yang awak belajar form 5 kan, yang line magnetic field yang keluar daripada kutub utara masuk kutub selatan. Because dulu maybe 7,000 years ago, the magnetic field comes out from the south pole into the north pole because of this element yang liquid dalam planet bumi ni. Okay, dia affects everything. The gravitational acceleration as one of the parameters yang dia affect. Okay, and the earth is not a sphere. I've told you just now. Dia earth ni dia bukan betul-betul bulat, dia gemuk. Dia gemuk dekat bahagian equator atau khatulistiwa, dia kembang sikit, and earth rotates. Okay, these are the three factors affecting the calculated AG punya value dengan the measured AG. Measured AG maknanya awak ambil alat tu, awak pergilah ke Britain, awak measure apakah AG kat sini. Lepas tu awak pergi Afrika, apakah AG. Calculated is what kita guna R yang standard. Okay, R yang standard masukkan ke dalam persamaan. So kat mana-mana pun nilai calculated ni sama. Tapi bila awak bawa alat yang mengukur G ni ke lain-lain negara, dia akan memberikan nilai slightly different from the calculated AG. Okay, those are the 3 reasons kenapa. Okay, when you look at the image yang ada kat situ, density, saya tunjukkan anda distance from the center. When the surface, kita ada density yang paling kurang. As you go inwards towards the center of the earth, the density of the earth becomes more, lagi tinggi nilai dia, disebabkan oleh liquid ni yang mengkocak dalam jadi berat. Jadi density, ketumpatan dia menjadi lebih tinggi, right? Okay, when you look at gravitation, just now we look at gravitation bila daripada permukaan keluar. As the altitude gets higher, okay, the value of G dia lagi kurang. Okay, on the surface of the earth, even though you say is 9.81, it may slightly differ the value disebabkan tempat-tempat yang berlainan. Okay, slightly bukan 9.81 dengan 10. Dia 9.81 maybe dengan 9.82, 9.83 macam tu. Okay, now we are going to see gravitation inside the earth. What happens inside, di bawah permukaan bumi? So, Newton keluarkan satu lagi theorem yang mengatakan, Newton's theorem states that a uniform spherical shell of matter exerts a gravitational force on a particle located outside the shell as if the shell's mass were concentrated at its center. Ini ayat dia. Okay, when you tengok, you tak faham pun. So, in other words, it is saying that a uniform shell of matter exerts no gravitational force on a particle inside it. So, dalam erti kata lain, daripada Newton's theorem ni mengatakan bahawa gravitational force makin lama makin ke center of the earth, dia makin berkurang sampai tahap at the center of the earth, the gravitational force is zero. Right? So, okay, ini ada dia punya hypothesis. Gravitation inside the earth, dia mengatakan bahawa if the density of the earth were uniform, okay, it is not. Okay, but if it is, the gravitational force acting on a particle would be maximum at the earth's surface. Then the gravitational force would decrease as we move outward from the earth's surface. Okay, betul lah. As the altitude gets higher, okay, lagi jauh daripada permukaan bumi, the gravitational force akan decrease. Tapi dalam reality, density of the earth is not uniform. Okay, disebabkan liquid dalam tu. Then apa yang jadi adalah the gravitation force will increase slightly as we move inward from the earth's surface, and it will reach maximum and then decrease at the center of the earth. Okay, ini dalam bentuk statement. How we showed it is this way. Okay, variation of AG with depth. Okay, when you look at, okay, yang ni bumi, yang bulat tu bumi. Dia ada satu kosong tu dekat permukaan tu, kita kata distance from the earth surface. Okay, awak tengok kita buatkan dalam bentuk graf, di mana paksi Y ni adalah AG, the gravitational acceleration, dan bahagian X ni adalah R. Okay, as the altitude of the R gets bigger, bukan altitude lah, distance dia lagi besar dari center of the earth tu, okay, then you look at the force, the gravitational potential tu, dia makin kurang. Tapi dia bukan linearly dia keluar kurang, sebab dia R squared. R squared is an exponent punya, quadratic punya form. So you have the graph macam curve, it will never reach to zero. Dia takkan bypass zero, dia takkan pintas dekat zero. Dia akan bentuk dalam bentuk eksponen, dalam bentuk square root tu. Okay, jadi awak akan dapati nilai AG tu akan berkurang as you go further from the center, from the surface of the earth. Okay, then you look from the surface of the earth going into the center. Okay, dekat situ disebabkan yang tepi ni R dia times 10 to the power 6 is very big. But kalau kecilkan dia punya graph, you can see as you go inward, slightly inward lah, 200-300 km ke bawah permukaan bumi, the magnitude of the AG goes meningkat. Okay, sampai satu tahap dia maximum, then dia decrease secara linear sampai ke center of the earth, dia akan jadi sifar. Okay, so this is how it looks like bila kita tunjukkan nilai AG ni daripada atas permukaan bumi dan dalam permukaan bumi. Okay, this is how it looks like. Okay, so this is my first lecture on gravitation. Okay, saya akan ada satu lagi lecture on Thursday. Saya akan sambung on this topic. Okay, so for this hour, saya habis kat sini. You have looked at Newton's law of gravitation. Awak dah tengok gravitational acceleration. Okay, you have seen how the gravitational acceleration differs. Magnitude tu berbeza dari segi altitude, the distance from the surface of the earth, bagaimana nilai Ag itu berubah. Dan you have seen going into the surface of the earth to the center, how the value of Ag itu berubah dari segi magnitude. Okay, it decreases linearly sampai tahap to the center of the earth, dia akan menjadi sifar. So, saya berhentikan lecture ni kat sini. I will see you in my next lecture. So, Assalamualaikum dan salam sejahtera.